So here we go with chapter 7.1, multiplication properties of exponents. And so basically what we're going to do here is look at just really quick look at the properties of exponents that specifically involve multiplying monomials. And we'll do a couple of examples of those. Talk a little bit about simplifying expressions using those multiplication properties. And then this is going to be a little bit of a 2-for-1 in that we'll look at 7.2 and the division property of exponents as well, and a couple of examples. Won't go into a whole lot of detail, tons of examples here. We'll do a lot of that in class, but I want you to at least see and have something that you can refer back to. So here's our first rule. It's called the product of powers rule. And so what's happening here is we have a base, b, that's being multiplied by itself, and it has two different exponents. So b cubed times b to the fifth. And the rule says, the property says that those exponents are going to get added, right? So we're multiplying b's. 3 plus 5 is 8. Multiplying g's. 4 plus 6 is 10. Okay. Now the underlying thing that's happening here is we've got b cubed, which is b times b, which is being multiplied times b to the fifth, which is 5 b's all being multiplied. And all total, right, we're multiplying. So there's our 8 b's right there. And we did that by taking the 3 and the 5, 3 plus 5, and that's where our 8 comes from. All right. So let's do an example here, give you a chance to see one. So simplify the expression. 6n cubed times 2n to the 7th. So this rule specifically refers to the exponents, and we've got n cubed times n to the 7th. And we'll pull those out here. Multiplication lets us do a little association, commutative associative properties there. So n cubed, n7, adding those exponents, we're going to have n to the 10th. What do we do with the 6 and the 2? Okay, those are not bases. Those are coefficients. They're just numbers. Okay, the 3 and the 7 over here, those are exponents attached to bases of n and n. Right, so that's why we add those exponents. 6 and 2 are just numbers. They're coefficients. And multiplication says 6 times 2 is 12. And so 12 n to the 10th would be my solution here. Okay. The next product, the rule that we'll look at, property we'll look at, is the power of a power rule. And so we have here in the parentheses b cubed, and that whole thing has been raised to the 5th power. So here's what's happening. We've got a b cubed times a b cubed, and we've got that 5 times. Right? That's what that to the 5th power means. So the rule we just looked at says that when we multiply the bases, we get to add their exponents. Right? So 3 plus 3 plus 3 plus 3 plus 3. This would be b to the 15th power. Right? Well, the easier thing to see here is that b cubed 5 times is going to give us 3b 3 times 5, right? Or b to the 15th, right? So all of this is why this rule works, but this is how we work the rule. Like a number outside that parenthesis there says this entire parenthesis has been raised to a power to a power. 3 times 5 is 15. Here's another example really quick. Okay, so w squared cubed, 2 times 3 is w to the 6th. Okay, so let's go and talk about simplifying just a second, because what simplifying means is that I'm only going to see every variable once. Right, so I'm not going to have x in 2 places or y in 2 places. I'm going to see each variable only once. There are going to be no power of powers. In other words, all of my parentheses have been taken care of. All of my exponent outside of parentheses have been taken care of and dealt with. No powers of powers. And then all of my fractions have been simplified. Okay, we work on that constantly, probably since, mid chapter 1, chapter 2, and then even years prior, like we simplify fractions. That's what we do. So here's an example, and this one's a little more complicated. It's a little more complicated, so I want to walk through all of the rules that are happening here. And guys, look, this involves order of operation. This involves everything that we've done up to this point that tells me here are the rules that we follow. So the 3xy to the fourth, like we're just going to leave it alone for a second, because what I see here is I've got a parenthesis raised to a power, and so that has to happen. And then all of that is still in brackets that are raised to a power. Okay, and so all of this has to be done before I can come up here and deal with this other parenthesis. So 3xy to the fourth, it's just going to be happy waiting right there until we get ready for it. And then I'm going to go ahead and make a note here that I've got a bracket cubed. Okay, so we're going to do the stuff that's inside here, but then that bracket cubed is waiting on me. So here we go. -2, that's a number, a coefficient being squared. So -2 squared, -2 times -2 is 4. Y to the first squared, so this is power to a power. So that's why 1 times 2 is 2, and that gives me a y squared. Okay. So I still can't put these two parentheses together yet. I like to go ahead and multiply those, but I can't because I still have an exponent to deal with. And order of operations says that exponents comes before multiplication here. So the 3xy to the fourth is going to have to be patient. Wait just another minute. So here we go. 4 raised to a power. So 4 cubed. 4 times 4 times 4. It's going to give us a 64. And then y is y squared cubed. So that's a power to a power, right? It's being raised to a power. So that's multiplication. 2 times 3 is 6. So we got 64y to the 6th. Now all of my power to powers, all of my exponents outside parentheses have been taken care of. So now I've got a monomial times a monomial. The 3 and the 6, they're both just numbers. They're coefficients. And we multiply coefficients. 3 times 64 is 192. Okay, there's only one x there, so the x gets to come over here just as it is. And then the y4 and y6, like we're multiplying, so we add those exponents together. 4 plus 6 is 10, and then that would be our final answer. Okay, simplifying, doing everything that we can, right? Leaving nothing duplicated, right? There's only one x, there's only one y. All of the numbers have been multiplied together. Okay, simplifying. All right, so let's go ahead and jump into then the division properties of exponents. Okay, and these are kind of, maybe we've not seen these yet, or maybe haven't seen these in a while, but notice that we're dividing. And so with division, same base, we subtract exponents. So c to the 11th divided by c to the 8th reduces to 11 minus 8, or c cubed. Okay, r to the 5th, r squared. 5 minus 2 is r cubed. Now that one's a little smaller, so I'll show you what happens over here. So that means that we've got r times itself 5 times in the numerator, r times itself twice in the denominator. And so simplifying fractions, r divided by r is just 1. It cancels. R divided by r, 1. It cancels. And now r times r times r is what I have left over, which is r cubed, right? So there were 5 r's on top. There were 2 r's on bottom. 5 minus 2 is 3. And that's why we have r cubed. Okay, here's another one. Okay. Now we can only combine the like variables, right? So we look at a single base and we do our subtraction, right? So this problem, when I'm done, I'm going to have x's and I'm going to have y's. So on the x's, we've got 3 minus 2, which is x to the first. Now we don't have to see that 1, but I want you to see that we've done it. So there's x to the first times, you don't have to show that to me, but I'm showing that there's space in between the variables, 4 and 1. So 4 minus 1 is y cubed, okay? Which I would probably simply write as xy cubed, okay? Either one of these would be correct. Xy cubed is the simplified form, okay? Now, there's also this this power, this product, this property that says an exponent outside of a parenthesed fraction, like that exponent goes to the numerator and the denominator. Okay, so for a problem like this, say, notice that the 3 is going to be cubed. We'll go ahead and work that one out in just a second. The x, so the 4, right, is being raised to the third power. So x to the 4th cubed, that's that product of a product thing happening there. So 4 times 3 is going to be x to the 12th. And then the denominator there is still going to get that exponent of 3. Okay, and then all this gets simplified, right? 3 cubed is 27. 4 cubed is 64. And there's our x to the 12th. And everything that can be done has been done. But all this to show you that that 3 exponent belongs with everything in the numerator and everything in the denominator. Okay? Still following our other rules, our other properties, and then simplifying. Okay? So the zero product property, this one is kind of fun. It shows up in some odd places on occasion. But anything raised to the 0 power simply equals 1. Anything raised to the 0 power, any non-zero number, anything raised to the 0 power is 1. Okay? So when I see an expression like this, that's a lot. And we could work for a few minutes if we wanted to cancel out some n's and some q's and r's and get things in the right place. But what I notice here is that entire parenthesis is being raised to the 0 power. And so based on the rule that we just did, that 0 exponent belongs to everything inside there, this entire expression reduces down to simply 1. Now that's because everything there, everything inside the parenthesis gets that 0 exponent. Okay, so the whole thing reduces 1. This one is a little different. The 0 is only attached to one variable, so it's the only variable that changes to a 1, that is evaluated as a 1. Okay, so we have x's, and 5 minus 3 gives me x squared. Y to the 0 is just 1, and so x squared times that 1 is just x squared. Okay, so anything to the 0 power simply equals 1. That's one of our division property rules. Okay. Last one we'll look at here, and this is the negative exponent rule. A couple of really good examples here. So anything with a negative exponent doesn't want to be where it is. It wants to go somewhere else. Okay. Negative exponents create reciprocals. In other words, 2 to the negative 4th here doesn't want to be 2 to the negative 4th. It is in a numerator here. It would rather be somewhere else. And the only place for it to go is down here to the denominator. So 2 to the negative 4 moves to the bottom. And now it's 2 to the positive 4. Which for us, we can go ahead and evaluate that. 2 to the 4th is 16. So 2 to the negative 4th is 1 over 16. Negative exponents in the denominator don't want to be there. They want to be somewhere else. Creating the reciprocal moves them to the numerator. Okay. So n to the negative 5 times p to the 4th divided by r to the negative 2. Those two negative exponents cause their bases to move. The p to the 4th is positive, so we leave that p4 where it is. The n to the negative 5, that negative exponent has to move to the denominator. And instead of a negative 5, now it's a positive 5. R to the negative 2 doesn't want to be down there, so it moves to the top, and that negative 2 is now a positive 2. If there was anything else that would simplify, we would do that here. But that's what the negative exponent rule says. I don't want to be here. I want to be somewhere else. Whether that's numerator or denominator, evaluating a negative exponent is what moves it to the other place. Okay?